Okay. Good afternoon. Welcome to Wednesday afternoon in Anaheim. My name is Martin Lovell. And for me, this Build conference has had a lot of resonance with the last time I was here for a developer conference. I was 23 years old, just out of college, and I came here for my first visit to America to see the Windows 1995 PDC. And that was a pretty auspicious moment in my life. I visited the country I'd never visited before. I saw Craig Brockschmidt talk about Ole 2 and make it sound vaguely simple. And most importantly of all, I got food poisoning during Bill Gates' keynote. So from my personal perspective, Stephen's keynote yesterday, in which I completely failed to go to the bathroom, was a major step forward. Okay, after that conference, I joined Microsoft in 1996, and I've spent most of my time working on one kind of developer technology or another. I spent a lot of time in the developer division, working on an IDE, working on debugging tools, working on libraries and languages for native and managed code. And about 4 or 5 years ago, I moved over to Windows. And in Windows 7, we worked on a variety of different APIs. And as I tried to build great developer platform for Windows 7, we ran into some pretty fundamental challenging problems. And we started to think, what would it look like if there was a better developer platform? What would it look like if there was a developer platform that provided greater flexibility, greater choice? And this started to bring together a set of ideas that were eventually to become the Windows Runtime. And so I'm super excited here to talk to you about something that is, for me, the culmination of many, many years of my life and of our work at Microsoft. You know, when I first joined Microsoft, my mentor was a guy called Dale Rogerson. And he wrote a book about a developer platform that I considered very, very exciting, but he mostly considered a good way to talk about helicopters a lot. But that book and other learnings about APIs form the foundation of what we're going to talk about here today with the Windows Runtime. My current role is that I'm the development manager on the Windows Runtime developer team, which means I spend my time managing a group of nerds, writing a little code, understanding what's going on, and I got the chance to bring to you this great new technology here today. My team owns the core of the Windows Runtime, and that's what I'll be talking about today. There are many, many APIs in the Windows Runtime. There are graphics APIs and printing APIs and XAML APIs and many, many other kinds of things. But I'm going to talk to you about the core technology, how it fits together, how the Windows Runtime works, how it appears natural and familiar in all the languages you want it to appear in, and how you can make use of it to build really great Metro-style apps with the great tool set we've given you today, or yesterday by now. Which reminds me, how many people here have already started trying to build an app in Visual Studio with their new tablets from yesterday? Hands up. That's a great job. Good job, guys. Thank you. Build apps. This is what we want to see, lots of app building. I'm here to help make your app building life easier, and I love to see those hands up. Okay. So, what I'm going to talk about today is what the Windows Runtime is, why we did this, what the architecture is, how it fits together. But mostly, I'm going to guess that you want to see me write code. And you know, there's two things when you see a guy with the word manager in his title on stage writing code. One is manager writing code, very scary, obviously, not something we want to see. And the other is, when will he make his first mistake? Well, I'm going to be writing code today in 3 different languages, so you should see your fair share of syntax mistakes as I fail to remember that C++ has 300% more dots than JavaScript when you're moving between things. You know, those colons, they add a lot of value. So, that wasn't a big enough laugh. Harry, I told you that joke wouldn't work as well as you said. There you are. Okay, so I'm going to talk about the inside of Windows Metro style app. I'm going to show you some stuff in the debugger. I'm going down into some low-level tools. We'll see how things fit together. And I'm going to tell you about what Windows Runtime's objects are, how they fit together, and what we use them for. This is a 300-level talk, so I'm going to be in real code. If you find it scary when I go into the IDE, you may want to leave now and make space for someone who actually is a nerd. Okay, so let's talk about what the Windows Runtime is and the new platform we're introducing with Windows 8. So you'll have seen this picture yesterday describing the APIs available to Metro-style applications. And this is one view of the Windows Runtime. It's the what can it do for me view of the Windows Runtime. And in fact, not absolutely every API on this slide is a Windows Runtime API. Some things are done with classic Win32 APIs you're familiar with. Initialize critical section is still initialize critical section, and it's down there in the low-level fundamentals. But almost everything you see here is a modern Windows Runtime API that provides you with attractive natural access to the core of the Windows platform directly calling into it. And so I'm not going to talk about most of these APIs. In fact, there are hundreds of talks this week talking about the specifics of each of these boxes. I'm going to talk about how these APIs come together, how you can use them, how you can make Windows Runtime work for you. And so where you saw this picture yesterday in Alesh's talk, I'm going to show you a deeper dive below this picture into the green box in the center, into the Windows Runtime itself. So what is the Windows Runtime? Windows Runtime is the solid, efficient foundation for building great Metro-style apps. We bring you the full power of the Windows platform to developers, no matter whether you're a JavaScript developer, a VB developer, a C# developer, a C++ developer. The Windows Runtime is there for you, enabling you to build great Metro-style apps with a great tool set we built for them. In this talk, I'm going to talk to you about how the Windows Runtime enables developers to get to things easily, how it enables each language to work, how that works at the low level, what's really happening inside Windows, and show how that all fits together. Okay. Here's a Windows Runtime architecture slide. Most scarily, it's going to build up in pieces, which means I must be some sort of PowerPoint whiz. Okay, we have the core of Windows. This is the Windows that you know and love. It has a kernel, it has user mode, it has services, and the Windows Runtime is the exposure of that to you. It's not a layer on top of it, it's part of that core Windows, but in this picture I'm drawing it on top to show you the pieces I'm going to break out during today's talk. So the core of the Windows Runtime, the piece my teen zone, it's about types, it's about interfaces, it's about binding up to languages. That's the essence of how the Windows Runtime fits together. On top of that, we build a bunch of APIs, many, many APIs new for this version of Windows, and we create metadata. We create metadata in a Windows namespace to let you get to those APIs in a natural, familiar, easy way. And we'll talk about all of these things. On top of that, we have something called a language projection. This is something we'll spend significant time on today. The language projection is how a Windows Runtime API is exposed up into each different language in a different way. Each language has its own notion of projection. Each of them works differently, and each of them is really cool. On top of those projections, I'm pressing the wrong key. On top of those projections, you build your Metro-style app directly hitting the Windows platform. Now, you might need a little bit of help for this. There's three other things we're going to talk about today a little bit. You might use the runtime broker, which is a separate process where managed pieces of the system live. I mean managed in the sense that they are controlled access things like your webcam that you don't want apps to be able to get to without the user's permission. There's the web host, which is where web technology-based Metro-style applications live. And there's the language support libraries that each language needs. You know, if you're writing in C#, you're using the CLR to get your language done. If you're writing in JavaScript, we have this nice library called WinJS that really provides you a great way to get the most out of the JavaScript platform. And of course, if you're writing in C and C++, you have the venerable CRT, which I was once also running at Microsoft a long time ago. Okay, that's the architecture. So why did we go down this path of having a new developer experience at all? You know, we had the Win32 platform. It's been with us for a long time. Many of you already know what Create Window does and other things. But these new Metro-style apps we wanted to build were different. We knew we couldn't get a great set of fluid apps from our developer community if we gave them as a starting point the existing platforms we had. You know, you saw yesterday how we had a bunch of interns start for 10 weeks and build some pretty attractive-looking apps, which you've now had the chance to play with in person. And we're pretty confident that with our existing platform, there is no way those interns could have made that achievement. So we wanted apps that were fast and fluid. We wanted those apps to be fully immersive. We wanted them to be trustworthy. These fundamental principles meant we needed a fundamental change of the platform, and that's how the Windows Runtime came into being. But beyond that, we wanted two things that are very specific to the developer experience. We wanted a really, truly great IntelliSense experience and browsing experience and debugging experience. So there's a dramatic improvement in developer experience. We weren't willing to tolerate the level of developer experience we had at that point. We needed to raise the bar so developers could do this in a much more easy way. And of course, we wanted freedom of choice. We wanted you to have the free choice of XAML or HTML. We wanted you to have the free choice of your language. We wanted to have you the free choice to use this open source library, that open source library, this piece of code that you have existingly. So we wanted that freedom built into the platform so you weren't driven down the one true Microsoft path. And that's the foundation principles for the Windows runtime. Now, what does that lead to in design principles? Well, beyond that major improvement to developer experience, we wanted a responsive and fluid platform, and as a result, we built async very deeply into our platform. You'll notice how much async stuff there is in these presentations, and my colleague Ben Kuhn is giving a great talk on async soon. This async is deeply baked in because we want responsive and fluid apps. And what we had learned from earlier iterations of our platform is that if we give developers the choice of synchronous or asynchronous API, as we did in, say, the file APIs in the Windows platform, people will pick the synchronous API even when they shouldn't, and we result in lots and lots of hangs in applications, lots and lots of grayed out apps that are going off and doing things synchronously that should have been async. So we built that very deeply into the platform. We wanted an app-centric platform. I think this is kind of a theme that will have already become evident to you. We wanted to reimagine the Windows platform. Wow, I said reimagine. I must get a point for that somehow. We wanted to reimagine the Windows platform so that one app couldn't interfere with another, so that each app was well separated and the apps could deal with the operating system, but the apps weren't vulnerable to other apps, and so that the system would be more stable, more trustworthy. We could be more confident these apps were working right. And of course, we wanted platform-based versioning. We wanted it to be the case that when you shipped an app, the next version of Windows would come along sometime, and the app would keep running on that version. Your app wouldn't need to carry with it any part of the Windows operating system. There wouldn't need to be any complexity there. The platform was just right there with you so that you have apps keep running on future versions. Okay. So with that done, I'm going to start by showing you some code and show how this stuff really works. So let's start by creating an app. Okay, so I'm going to create a Windows Web Technology-based Metro-style application. Oh, switch screens. Good point. Thank you very much. Okay, I'm just going to create this app. Still, no? Fascinating challenge. Hello. I can make this work. Monitor's just a little bit further to my right. Okay, I'm going to create this JavaScript-based application. Now everyone can see this, right? It's not just me. Okay, and we'll see some very familiar stuff. We'll see some HTML code, and you know, like any good developer, the very first thing I want to write here is hello world. But because, you know, we've made a bold and reimagining of the Windows platform, I really think I should put this in bold. So we'll do that. And, you know, if I were to F5 this app, it would run, but I think that's not super exciting, so let's do something. Okay. So now you'll see the JavaScript code that lives inside this application, and you'll see us using the Win.js library, which I'm not going to talk about right now, but Luke Hoban will talk about in this room just afterwards. And I'm going to type Windows dot. Now, typing Windows dot doesn't seem like the world's most great achievement, but it took an amazing amount of work for this little thing to work, and we're super proud of this exact thing. So Windows lives in the Windows namespace, and in all of our languages, you can see it there, and you can browse around, and the Windows namespace has a decent number of relatively well-understandable things in it. The purple things here you see are really things that JavaScript is providing, and everything else is a Windows namespace. And so I can browse around this Windows namespace and see what the pieces are, and see the structure of the Windows runtime, and see the structure of the APIs provided, and all those things are there and available to you because we provide metadata on the system that JavaScript can use dynamically to understand the Windows APIs and to see what's available. Now, this is a critical part of the Windows runtime vision, is that you may have noticed that occasionally we have a couple of APIs for the same thing. You know, maybe a couple of media APIs, a couple of graphics APIs, you know, throw in a few other things, and it can get kind of confusing to understand what it is we think is the recommended way to build a Windows application. And it turns out that right here, inside the intelligence window, we're answering that question. The stuff you should use to build a Metro-style application is right here in this list. This is all the stuff we recommend for building this, and it isn't littered with other technology that you might find difficult to understand what we're on about or find pollutes the namespace. This namespace is full of stuff that we think is highly recommended for building these kind of applications. We plan to keep it clean that way to make sure that it's always simple to understand what it takes to build an application. And of course, IntelliSense is only just one part of this puzzle. I can go into the object browser, and I can also search through for things to do with the Windows APIs. So I can look for sharing APIs. And of course, this is all based on metadata that lives with the Windows SDK, that lives with the Windows platform. So we have a full, deep understanding of the Windows platform. And I can look at any of these pieces and click on them and understand what methods they have. And when I click on a method, I'm going to get a description of that method. So you can see how we've hooked together the power of metadata with the Windows platform to make it always easy to understand what's available in this platform. And so as you search around, as you browse around, you're never going to be confused about what's available in Windows or what's available to you, because it's all just right here in the object browser available for use. Going beyond that, there is also another way to look at this data that's interesting. Let me bring up ILDASM. Now, most of you know ILDASM as something that's on the wrong monitor. Most of you know ILDASM as a tool that looks at .NET metadata, and it's a tool that does that. But when we looked at the Windows Runtime and how to make it, we reused the .NET metadata file format as the way we represented Windows Runtime metadata. Even though the Windows Runtime is itself fully native code and part of the core of Windows, we felt that this was a metadata format that was well supported by tooling, and so it's right there. So if I go to File Open, and I go see Windows System 32, Win metadata, and then I do star.winmd. There's the Windows metadata. You saw it in the object browser, you saw it in IntelliSense, but here it is. You know, everything you want to do. Let's say we look at the windows.storage.pickers. I can look in here, and I can see the file open picker that you showed yesterday, and I'm going to show it again in a moment. You see the classes and so on. Now, this is not a perfect view, because ILDASM is really primarily still a tool designed for .NET. It's not a tool we're promoting as a tool to browse the Windows Runtime metadata, but it just shows you how this stuff fits together. This is how JavaScript got its data. It went to this exact file and opened it just like I did and ran through it and understood the metadata from right there. So it's all there in the system. The system is self-describing in a way the Windows system hasn't been before. The metadata self-describes the APIs available in Windows and lets any language, including JavaScript, including C#, get it at runtime, or any compiler that wants to compile it, such as C++, pick it up at compile time. So the metadata gives you everything. So let me show you how that works out in real code. Let me finish this thing, because I'm going to use this file open picker a lot. Oh, if I ever. And I'm going to create a new one of those, because obviously that's what I want to do. And I can call pick single file async, and then, and that's because it's an async method, so I have to tell it that I'm going to get it done. I'm going to press F5, big gamble, let's see if it runs. And you're going to be excited, thrilled, when the exact thing you expect to happen during a presentation happens and I get an error. It's an important part of the experience of a presentation. So this error lets me talk about another cool thing we did with the Windows Runtime. The Windows Runtime is ultimately, at its lowest level, an H-result-based system. It's a system that uses integers for error codes. But then all the languages it wants to be in are exception-based languages, and so the projection converts this H-result into an exception. But while we were doing that work, we also looked at how people dealt with errors in Windows and how frustrating it was in general when an error came back saying access denied but completely failing to tell you what access was denied to or where or when. And so we build a mechanism into Windows which allows a direct communication between the moment Windows discovers an error and the debugger that is attached to the process, showing what context there is about the error. And so in this case, the Windows core communicated to the debugger that there were file type filters property must have one file type specified. I'm sorry, my microphone is... OK. And how does that really play out? Well, let me show you the code again and fix this, because I've obviously got a bug. So we'll do fp.filetypefilter.append. Quote.jpg. So in this filter, I'm just adding the JPEG file filter. I'm going to press F5 again, and now I've been able to fix my bug. And the app has come up on the wrong monitor. Now that turns out to be a problem. OK. This seems to be... I need to let you see that app. Wow. This is the problem I did not anticipate. I'm going to have to duplicate for a moment. Apologies, this... everyone can see that. Press F5. And here it is, the file open dialog. Woohoo! Round of applause, please. That's about the right level. Thank you. OK. So let's go back to the demo environment and look at that. Now, obviously, you saw I did something very simple there. There's nothing very clever about that. But ultimately, I want to switch back and talk to you about what we really saw there and how that fits into the system as a whole. OK. So what we talked about just now was the Windows namespace and metadata and how those things fit together. The Windows namespace and metadata provide the core of understanding the platform. Windows metadata is a concise, complete description of the Windows platform generated natively at the time we build Windows. So we generate metadata at the same time we build Windows, and you can generate metadata because you will produce Windows Runtime objects as well for your own apps, and you will generate metadata automatically when you build C++ or C# or VB-based Windows Runtime objects. That metadata format is CLI metadata, using the same structures, but really slightly different meanings for those structures. But using that metadata helps it to be easy for the C# and VB languages to get to our metadata, and it also makes the tooling story a lot simpler overall. The metadata is rich enough to allow multi-language projection generation. It knows a lot more about Windows than, say, Windows.h used to. You know, you were lucky if Windows.h would tell you that a function returned an integer and took an integer. It knew basically nothing about how functions work together. Windows.h doesn't tell you that create window pairs up with destroy window or any of those things you might want to know. But the Windows metadata has a much deeper understanding of the system. And of course, it gives us full IntelliSense on the statically known information. The Windows namespace is a tidy place, an easy place, a place you can find the Windows APIs you need to find. Great IntelliSense, great browsing, one clear type for each type of function. And there's a catalog. This metadata and this namespace are described in the catalog. It lives in the registry. But that's only for the Windows stuff, and then your app can have its own Windows Runtime objects that are private to the app. There is no way for one app to expose Windows Runtime objects that another app consumes unless those two things work via the contracts that go through the OS, like the sharing contract, where it's mediated by the OS. So the catalog is extensible but private to your app. This goes back to our point that this is an app-based platform designed to create stable, separate apps, not collections of things that interact with each other and create a less stable system. And finally, your Windows Runtime objects can be seen from JavaScript. So if you need to build a HTML and JavaScript-based application, and then you need to call down to C++, you can use that by exposing that C++ code as a Windows Runtime object that is then callable from JavaScript. But of course, only the JavaScript in your personal app. OK. So what else you saw there were functions that took some basic types. I don't want to spend too much time on types. I'm pretty sure everyone in this room understands what an int is. However, we did create some interesting stuff here, and I want to talk about 2 or 3 things. And the first one, kind of the most basic, is we did create a new string type in Windows. And that was because we wanted to make it really easy for there to be no data copying when JavaScript calls down to Windows, when C# calls down to Windows, and when C++ calls down to Windows. And it was critical to our design that we not end up with a new layer here that added a lot of performance penalty relative to calling from the app to Windows. You see that box called projection in our system? We need that projection layer to be as thin, as efficient as possible, because otherwise it's going to get in your way of getting directly to Windows. So we created the hstring type, which you will see in your languages either not at all or not very much, because your languages will use their existing string types, and then you will pass it down efficiently to the Windows runtime. There's 3 other things I want to talk about here. Ultimately, the Windows runtime is an interface-based system. Each block of functionality in a Windows runtime object is bound up into an interface, and that interface is the foundational type of every method call in the Windows runtime. But interfaces are relatively complex things, and they're necessary so we can version the operating system, but they're not something we want you to see day to day. So mostly, you will see the things in terms of runtime classes. And these runtime classes are collections of interfaces that can evolve over time. In Windows 8, a runtime class might have 3 interfaces. In Windows 9, it might have more interfaces. A runtime class is a collection of functionality, and it appears at a specific place in the Windows namespace. So that place is known to have a certain set of interfaces, and the metadata tells you that collection, so it was all pulled together automatically. Finally, I want to briefly mention generic interfaces. I don't have time to go into all the details here, but we did add a new kind of interface, which is types generic, which allows you to have a vector of integers or a vector of objects or a vector of enums or whatever. So these things can be bound together in a type-safe way, and you're not stuck with type-unsafe collections in any scenario. OK, let's go back to the demo. OK, so I'm going to bring up another copy of Visual Studio. In fact, another 2 copies of Visual Studio eventually, but we'll start with 1 at a time. So, wrong copy of Visual Studio. So this time, I'm going to create a C++ app to start with. And so what I'm going to show you in this demo is how the projection layer interacts with C++. So I'm going to create an app, and I'm going to set a breakpoint in Windows and kind of show you the call stack between the two and show you how the projection fits into the system. So let's do that. And you'll see I have a XAML-based app here. I'm going to go into this app. And just like before, this is when my syntax gets really challenged, as I try another language syntax. And this one. So one of my favorite language features in C++ is the new auto keyword, because it stops me having to type things twice in demos. So it's extremely valuable. Ref new. Sorry. So we have to set the file type filter. We already know that. Sorry. JPG again, and FP arrow. Now, there's something interesting here. We're going to pick a single file, and we're going to do that, and it's going to get us back it's going to give us back an async operation object. And then that would allow us to start the async operation. And this is showing you the core of the async pattern here, which will show you later how in C# it's made simpler with the await keyword. And Anders has a great talk on that as well. But for right now, what I'm actually going to do is set a breakpoint somewhere, so I can show you what I want to show you. So if I set this in shell 32, bang, DLL get activation factory. So that's a breakpoint in the shell 32 DLL, which I should have said shell 32 DLL, I think. in the DLL get activation factory, which is how a Windows Runtime object gets initially created. So that Windows Runtime object is called into shell32, which is part of Windows, and asked to be created. And this is how the file open picker is going to get called. And I'm going to press F5. And while this is compiling, I'll tell you that what's interesting about this situation is that what I'm trying to show you is that the C++ projection provides a thin layer between shell32, which is a regular Windows DLL, and your app's code directly. And so there's as little code there as possible, and you can see how we've used natural C++ features to get in here, like auto and so on, and we're just getting directly into the underlying OS code as quickly as possible. Okay, so I'm going to set a breakpoint here. I'm going to disable my shell32 breakpoint for right now. And my breakpoint has hit. Now, in this call stack window, which can everyone see the call stack reasonably well? Is that a good? Okay. So in the call stack window, you'll see that here is your application that we're in right now, and then and we're waiting to call this launcher. In fact, there's already stuff on the stack from Windows that called us to get to here, but I'm going to ignore all that stuff and and enable my breakpoint and press F5. And what you're going to see now is not the right thing. Okay, that didn't work as I expected it to. How are we doing for time? I'm going to keep going. What you would have seen there, had I been able to show it to you, is the Windows shell on the stack, and underneath it, directly the code inside VC that marshals that call, and then the application. But for some reason, the breakpoint didn't hit, and given that we are relatively tight for time, I'm going to move straight on and do the same thing in C# and show you something interesting about that. So I'm going to stop debugging and create another new project and another new instance of VS. So what's interesting about the C# version of this is that it's going to look significantly different than the C++ version because async operations are projected differently into C#. And that's kind of one of the key points of this presentation, is that we have a projection that is language specific, and each language gets to talk about these things in its own way. And so when I go to this app here, and I do the same kind of thing, and I'm back to dots from double dots. And in this case, I'll do var foo equals new. Same one. And then I'm going to turn this into an async method. And then, of course, I'm going to do the usual dots and arrows. And you notice how that was add, not append. You know, so because we're in a C# environment here, and we'll pick single files async, and what I'm going to do then is await that. And awaiting it is saying I want that to get asynchronously executed in this async. Oh, yeah. Too many different syntaxes. And here's the file open picker again. And so you see how I showed you 3 different instantiations of the file open picker. And in each case, it fits into the language neatly and naturally, using the language's natural constructs and enabling you as a developer to feel natural and familiar about that. And now we have a black screen. So let me go on and talk about what we talked about there. Okay, we showed you the language projection, and aside from one little snafu in C++, we showed you how each projection provided a different level of functionality, a different integration into the environment, and provided you with that natural and familiar view. So this is a good time to talk about what is a Windows Runtime object really. What is the projection, what's the layer between the projection and the application? So Windows Runtime object at the core is an object that supports interfaces. And here you'll see a diagram that may look pretty familiar. Each Windows Runtime object supports IUnknown, which is a very classic long-term Microsoft interface that has add, ref, release, and query interface, and familiar from long ago. But we added another standard interface to IUnknown. In fact, I wanted to call the other interface IKnown, so we had unknown and IKnown, because that seemed like a simple way to go. But it turns out that when you say IKnown pretty fast, it sounds exactly like you're saying IUnknown, and just confuses people. So we ended up with IInspectable, which sounds rather like a cartoon character, but there you are. And so IUnknown and IInspectable describe an object. And IUnknown is the unknown object, the object you don't know anything about, but every Windows Runtime object is IInspectable. You can ask it about itself, you can understand it, you can get to its metadata, you can work with that object's type. And then obviously, an object has interfaces that actually do stuff. In this case, the example I have is a file information class, which has 3 interfaces: information about an item, information about a file, information about information about an item, information. Those 3 bunches of functionality are there inside Windows, but in your app, you will just see one thing, a file information class with whatever number of methods it has, with 17 methods. You won't see these interfaces unless you need to see them for some unusual purpose. In general, we've mapped these up. But then this object is activated from the activation store in the registry, as I talked about, and stored in the Windows metadata on disk. OK, so having created this object, how do projections get to it? Well, if you're a C++ application, you get to it at compile time. The compiler reads the metadata at compile time. It automatically generates native code that talks directly to the Windows platform. And then at runtime, it talks directly to the object without talking to the metadata again. So a C++ app is just going straight against the projection using the compiler for that. If you're a C# or a VB app, you're talking to the metadata a little bit at compile time and a little bit at runtime. And it's a mixture of those 2 things. And but effectively, because the C# app and the VB app will be using a runtime callable wrapper, an RCW, to get down there with a very efficient Windows runtime wrapping, the cost of talking to the metadata at runtime is not very different to the cost of talking to metadata at runtime in the C# and VB environment in general. So that's a very cheap call. And then if you're HTML, JavaScript-based application, your projection is talking to the object via metadata, and that metadata is being dynamically generated into the projection at runtime by the Chakra engine. And so that is a purely metadata-based solution happening at runtime, and just like a dynamic language would be expected to do. OK. So let's see how that all fits together. I'm talking about the projection. I want to show you how objects get created and what steps are followed as objects get created. So the app asks to create an object. The app is blue in this case. That gets past the projection, which really just passes on a call to activating an object there with row activate instance. That, in turn, finds the DLL using the catalog in the registry, which is the Windows runtime code that my team owns, and loads the DLL, and calls into the OS code to get the factory. And then the OS code itself gets the implementation, returns it. Now, there are lots of steps here. But the thing to get an understanding of is that the layers between the app and Windows are extremely small. And the goal here is that the app is directly connected up to Windows, but showing you the role of this shows you each step in turn. The projection creates some kind of wrapper object at compile time. At runtime, that wrapper may have been created. You bind up the Windows runtime to the object, and it's returned to the app. So if you look at this picture, you can see how the app does very little. And in fact, the blue box, which is the app box, doesn't have to know about very much of this at all. This is all stuff I'm telling you about because I want you to understand how the system works. But in practice as an app, you'll just do new object name, new windows.storage.pickers, and you're set. Everything else here happened behind the scenes as we were seeing in that demonstration, and your projection hides that detail from you. OK, I talked about versioning a little bit, and I want to talk about it again briefly. The Windows runtime metadata provided you with Windows version 8 is the Windows runtime metadata for Windows version 8, and it includes all the stuff about Windows version 8. Now, what happens when a future version of Windows comes along? So in that version, the same object may have extra interfaces. those extra interfaces are added, and the metadata knows about them, and it doesn't just know that there is an interface, it knows which version of the operating system that interface came along with. And so the IntelliSense experience you get, the debugging experience you can get, can tell you what interfaces should be there for sure on the operating system and what interfaces are optional. And the language can choose to expose the interfaces up in such a way that you can tell in IntelliSense that the interface you're calling isn't available on all the platforms that your app is targeting. And so there's a fundamental connection here. One of the hardest things to do in Windows historically has been to write those adaptable apps, the apps that ran on 2 or 3 different versions of the OS. But as the Windows Runtime metadata moves forward, you'll always know exactly which APIs are in which version of the OS, and your IntelliSense and experience in the IDE will be to tell you about that. So you'll always be confident that you'll get the right kind of behavior, and if you want to call something you know is there, you can tell if it's really there because the metadata is telling you about it. So that's a really fundamental shift in how we describe our app operating system and its APIs. Okay, we're on reasonable time. I've got one more demo. I'm going to show you how collections fit together into this environment, because it's kind of interesting how the collections look different in each case. So I now have 3 apps. We've been looking at these 3 apps all morning or afternoon, and they're all using the file open picker in different ways. So let's start with the C# version, which is here. No, that's the JavaScript version. Let's start with apparently, the C# version, which is there. Quite sure how that ended up in that order. So what you might notice is that this file type filter, which we added the file types to, is some kind of collection. And I didn't spend much time on what kind of collection it was, but it is, in fact, a collection somewhere inside shell32.dll implemented in native code. It's a part of the Windows operating system. But then what I'm able to do here, if I can ever get the syntax right, why is that squiggling me? No, I think enumerator is right in this case. That's not working. Enumerator. There you are. So what I showed there, and you can argue that my mistake was a deliberate error. I think we should argue that. My mistake was a deliberate error to show you how type safe the system is. Credible, not credible, kind of in between. But as you see, as my little editing session showed you, the Windows Runtime types convert down to specific CLR types that are matched up to them. In this case, this file type filter converts down to an iList. It'll convert to other things as well, but it won't convert to everything. And so these interfaces inside Windows have been automatically rewrapped by the CLR into interfaces available to managed developers in a format that could then be passed on to any managed function that took an iList. And what has happened here, and this is super important, is we didn't copy the data. This line of code that I wrote doesn't do some magic copy of lots of strings into a CLR array. That would be, cute, but kind of bad for the real world. What we did instead is that this is a real interface over the Windows data, and it's calling down, and because these are strings in general, even the strings might get copied occasionally, but they won't necessarily have to be copied depending on what you do. So it's a very powerful abstraction here we built, and particularly the Windows Runtime makes it possible for you to work in C#, write efficient code, and get efficient results against Windows code that was written in C++ by other people at another time, and those things are bound together by these interfaces. So it's pretty cute, and you can work as you expect. Now let me show you another version of that that's even cooler, if you ask me. But of course, I have to get to the right IDE window. So let's imagine that I'm an SDL person. I could write something like this. Auto I equals std count if begin fp file type filter end file type filter And now I'm going to do something, this is where we'd have a drum roll if we had a drummer, because I'm going to write a lambda on stage in C++. And the number of punctuation marks required is quite significant. I'm just going to make it return true because it's a lazy lambda. Okay, so to show you this code in slightly more detail would require smaller fonts, but let me scroll over a little bit and show you what I'm doing here. So this is a real STL function, and I've called begin and end on a Windows Runtime collection. So again, there's not some clever layer here. What happened is I have a begin iterator for a Windows Runtime collection in C++. So if you're the kind of person who wants to work with STL iterators, they're directly available to you on the Windows Runtime collection. So again, Windows Runtime is natural and familiar with the environment that you work in today. And then as a flourish, I wrote a lambda function that just returned true, which is like the world's most useful lambda function. But to just show you that this is exactly the pattern that you have in STL and C++ today. So no matter what your environment, the Windows Runtime is behaving naturally and familiarly for you. And this is really critical. And again, in this case, the C++ is not generating any data copies. There's not a lot of extra overhead here. This is working directly on data coming from Windows, directly in the syntax environment that you love, and that's the magic of the Windows Runtime. Okay. So let's keep going, because we're almost out of time. Okay. The stuff I just showed you was the Windows Runtime core. There are a bunch of patterns I didn't have time to talk about. I showed you collections, and that we have obviously vector-type collections that are arrays, and we have associative arrays that are maps. We have views. We have a lot of collections. I've got a slide on that in a moment. We have these things called delegates, which are really callback functions. We have the event pattern, which lets you register for and understand how something has happened on the system as a whole. We have the property pattern, which allows you to collect bags of different stuff into a single place, especially that's used pretty deeply in the XAML framework. We have async, which I've talked about a little bit already, which provides us with the way to call and return and understand how things fit together. And we have these things called contracts, which you heard a lot about yesterday. And contracts are Windows Runtime interfaces that allow you to interact with the operating system and provide extension points for sharing, for searching, for all the pieces of your app as it fits together. So all these pieces of the Windows Runtime are patterns that we support across the whole system. And we've done an amazing amount of review and standardization here to make sure that wherever you're working with the Windows Runtime, these things are used the same way in all the different places. So you should find that we have really uniformized is really not a word. We've really made uniform these APIs. Okay, I showed you collections. I showed you a little bit of collections, but in fact, our collections types go for vectors. We have a vector view, and a vector view is not a window containing a vector. A vector view is actually a vector you can't modify. And then we have observable vectors, which are vectors that have events when they change. So those things connect up. We have the same thing for maps. And every language consumes those in a way that's natural to it, as I showed, an STL-style projection, an enumerable-style projection. And I didn't have time to show you the JavaScript, but in fact, that would look the same again. It would also consume these collections in a way that just looks like an array in JavaScript, in a way that's very natural and familiar for the JavaScript developer. OK. Later in this conference, Ben Kuhn has a talk on async objects. It's a great talk. His jokes are much better than mine. Yes, Steve, there's some sympathy there. And also, he has a great talk on how to make sure your apps don't hang, and using the async objects are what we do that. We wanted to make this platform as responsive, as fluid as possible, and we did that with async objects. Those async objects are in all the parts of the Windows Runtime where things might go on for a long time. As Alesh said, that's about 50 milliseconds, which isn't really very long in my book. And it makes it simpler. It would be simpler if we just gave you synchronous APIs, but then we wouldn't have a responsive and fluid system, which we absolutely need. So we built async into the basic API shape, and your language projections have an easy way to do that and get down there using await in C#, using promises in JavaScript, and the C++ folks have something coming too that they will talk about. I think Herb's talk covers that. OK. I didn't talk about this today, but I wanted to briefly touch on threading because I saw a bunch of questions on this, and this is an interesting topic. The way we model threading in the Windows Runtime, we have one primary thread, the main UI thread where UI stuff happens. And we think of that as like a single-threaded environment. And of course, if you're a JavaScript programmer, you're really in a single-threaded environment in general, apart from web workers. But You want the UI to be in a single-threaded environment because you really don't want to receive a click on the cancel button when you're halfway through processing a click on the OK button. It would be difficult to write code that would be useful for that. So the main UI thread is a single-thread environment, but all the real work, all the important work, gets done in the thread pool on async objects that actually do their work on background threads. And so we have Windows objects living on background threads, and almost all Windows objects can work in any of these threads. But of course, the normal threading environment for Windows object is if it's UI, it'll be on the single main thread, and if it's not UI, it'll be on the background, and that's how it works. But as a developer building an app, you will almost never have to think about this. You'll use async objects, they'll manage all the background stuff for you, and you will only have these occasional moments when you actually have to think about threading. For the majority of you, you'll live on the UI thread and do cool, responsive, fluid stuff right there. Okay. Another thing we talked about yesterday, without going into detail, I wanted to talk a little bit about how this works. We have brokered objects, and these are the objects that say to you, for example, is it okay if you use the webcam? And if you're like me and you're using the computer in the morning when you may not be quite fully dressed, then you'll be pretty pleased that that prompt exists. And the webcam prompt comes from the broker. And so what happens there is you see a projection that looks exactly like any other Windows Runtime object. It's there, it's in IntelliSense, you do Windows dot, and then automatically we proxy that call over to a call that happens in the broker process, which is a separate context, and then the UI gets put up from there. In fact, the pickers you saw being put up, those are being put up by the broker process because the picker is a privileged object that can browse objects that your app doesn't yet have access to. So many more things are brokered than you might realize, and as you can see, the broker doesn't have much overhead. The file open UI comes up just fine, but the broker provides confidence for the user that you can only get to the parts of the system you're supposed to get to. Okay. So I'm going to recap a little bit what I've talked about. The Windows Runtime is a set of APIs, but it's also core technology. It's an interface-based technology, but we use projections and metadata to make it easy for you in any language. And it's a technology that underpins the whole Windows platform, but it's not a technology that you need to understand in this level of detail to make use of it. In fact, those of you who are thinking, wow, I hope I don't have to understand this stuff very often, yes, you don't have to understand this stuff very often. But on the other hand, it will be very useful when you're debugging. And for those of you who are excited, then there's a lot more stuff here. Matt Murray has a talk. There are other talks I'll talk about. Ultimately, this Windows Runtime is a solid foundation for our platform. You can build these Metro-style apps easily. You can get Windows in your choice of languages. And most importantly, there's one Windows API for each thing, natural, familiar, in your language. Okay, so what else can you find out about this? So Matt Murray has a great Windows Runtime internal session, which is kind of the next level of drill down after me, and that's coming up, 875. Ben has async everywhere, and then after this session, right after this session, there are 3 sessions that you can choose between. In this room, Luke Hoban has a session about using the Windows Runtime from JavaScript, where he'll drill down on all the JavaScript aspects of this. In another room, Harry and Jesse have using the Windows Runtime from C# and VB, and they have a really great talk. And then in another room again, Herb Sutter of great C++ fame has a super talk on using the Windows Runtime from the great C++ environment they have. So each of those talks is right after this one. So in some sense, it's a pick your language of choice and go learn more about the runtime, and those are all great. I would be glad to hear your feedback, to hear your questions. I'm super excited about this project, about what we've done. And I know that there's many more aspects of this. I've talked to lots of people at lunch and elsewhere. Please drop by and talk to me at the apps booth. I'll be there with a bunch of other WinRT folks from today to 3 to 5, like right after this, plus more times. I'll do Q&A online. My email address is there. You can find me by Bing very easily. But I will be answering questions to the forums. And I think the forums are the best place to go with questions because there's lots of other people other than me answering those questions. So go to the Q&A at the forums, windows.com. Those forums are already pretty active. I already answered 2 or 3 questions this morning. So please go there and ask more questions. We are excited to have you on the Windows Runtime, and that is it.